Alright, this is the first step of making a giant rock tumbler, like 12-pound capacity. So I cut these out, just out of a piece of wood. This happens to be redwood, but it could be anything. And this is a 22.5-degree angle, so, you know, that makes an octagon when you're all done. I got a tub of glue here, and I'm just finishing the last row. There's 32 of these blocks, and there's 8 per layer. And I'm making sure that the layers align vertically. That's important when I go to cut out the final shape. So I only have a couple more. So these glue joints, they don't have to be watertight. We're gonna, you know, epoxy this thing to make it all watertight. This is just to hold it together structurally until I can epoxy it. Okay, so while the glue is drying, I cut out a template out of a piece of mat board of the outside diameter that I want. And I used a compass to draw it so it's nice and round. That's important because we're going to roll this barrel on a pair of rollers, and we want it to run reasonably true. The octagonal structure in there will cause the rocks to tumble and roll, and that's quite important to have some structure inside. I made one of the end plates for the drum, so that'll go on like that after this is cut out. I have a 4¼ inch diameter hole saw here. So I just realized before I cut out that center, I really want to have a bolt ring that goes around here that I can then use to pull a plate down and seal this thing. So I'm going to draw a bolt ring now. Okay, I got a nice big hole. Get my hand through it easily, which is important. And I've got a bolt hole ring drawn out here. All right, so there's the barrel, fully cured overnight, the glue. And now it's, of course, it's like bulletproof. So now I'm going to cut this out on the bandsaw. So there's the cutout barrel. That was actually really easy. Redwood is super soft, so it went quite fast. And here's the thing I cut out of it. It's kind of cool. Okay, so this is going to be the porthole cover. It's roughly 8 inches in diameter. And I'm going to center it up so that it's centered on here. And then I'll use a little bit of spray adhesive or something to keep them together while I drill the holes for the bolts. Okay, I've drilled the holes. And I've got the porthole cover in place so that, you know, it aligns itself. These are 5/16 holes for these carriage bolts. And I'll just remove this, but I want to mark the orientation. I've cut 6 bolts to the right length. And now I'm trying to figure out what to do, if I should epoxy these in right now before I go any farther, or whether it's okay to epoxy these in when I epoxy the rest of it. I think I'm going to try that latter approach. So all I need to do is to bang these carriage bolts in so that they register completely against this face. Next step is to glue these guys together. Here's how I decided to mask this off while I epoxy it. I have a piece of parchment paper, and honestly, I've never found anything that sticks to this. Certainly not epoxy. Right, I've mixed up 150 milliliters of tabletop epoxy. I'm just at the end of the bottle, so I'm just trying to get rid of it. I think anything would work, but these products work fine. They sink into the wood pretty good. So I'm just going to slather the bejeebers out of this to get a preliminary seal. Right, so there's the inside, and I mixed up way too much epoxy just for the inside, so I'm going to do the outside. And then I changed my mind on this end piece. I'm actually going to epoxy the end cap on right now. Why not? I'll be able to get at this end cap and that joint from the port. So this is just a preliminary coat. I can add more if I need it. Now since I got all this epoxy, I'm just going to do the outside. So that's easy. Well, with that 150 milliliters of epoxy, I managed to get the entire thing. I'm not going to disturb this. This will be overnight. I'll have to let it cure. So I'll do that and show you the result. All right, so I've just smoothed things out a bit. I think there's plenty of epoxy everywhere there. And I also had enough epoxy to do the port cover. The epoxies had overnight to cure, about 18 hours. And it's nice and hard. I'd say it weighs about 4 pounds. It's certainly not very heavy. And it's fully passivated in the sense that it's not going to leak, and I don't think this is ever going to rot or deteriorate. The epoxy makes a really nice waterproof coating. So the next step is to build a base for it and make it go around. That shouldn't be too difficult. So I have this piece of 1/4-inch neoprene. I'm going to use it for the gasket here. And I was thinking of making an O-ring, but I realized that I don't think there's any reason to cut out the center, which makes it a lot easier to make. And probably better because I won't have the rocks hitting this. The rocks will be hitting that. So, can it be cut out with a pair of scissors? I don't think so, but oh yeah. All right, so that's going to be easy. All right, there's the seal. I don't see anything wrong with that. And I've opened up these holes actually quite a bit from 5/16 to make it easy to get this on. So it's Maybe I should fill that with water and see if it leaks. That would be a good thing to do. Well, I didn't get it sealed very well around the bottom, did I? All right, so I'm going to have to pour another layer of epoxy inside. Is the obvious place to do it. I'm wondering if there's enough light inside of the chamber to take a photograph of it. To take a video of the inside of this thing. I have no idea what that's going to look like, but it's kind of interesting. Okay, so for the second epoxy coat to seal the leaks, I'm using this stuff. It's just really epoxy. It's a very thin epoxy, which is good because it'll easily run around the inside of this. So I've mixed up quite a bit because I'm going to roll it around the barrel and then let the rest settle to the bottom where the leaks are. Time for another leak check. So let's see, after pouring the another batch of epoxy in here, everything looks okay so far. I've got about this is filled up about 3/4 of the way. All right, I got that down pretty tight. Not as tight as I could, but I don't want to, you know, stress anything too much. So you can hear the water inside of it. So I'm gonna just turn it upside down and leave it for a while and see if any water comes out of it. Let's take a look. Drops, so that's a very good sign. Okay, so here's my idea for the drive. These are skateboard wheels. I actually had these from another project, and this is an 8mm shaft, and the skateboard wheel is designed to go into there. So for the drive, I'm going to passivate this, if I can, with epoxy. We'll see if that works. It might not, and if that's the case, I'll figure out some other way of getting a drive wheel onto the shaft. But certainly for the idler side, so this will be the idler side, I don't need to do anything. I'll just, you know, fasten this shaft to the board like that. Over here, what I have is a 8mm coupler. And this stuff is, you know, really pretty inexpensive when you think about it. I think, you know, this is less than $5 for the coupler, and the shaft is $5, and I don't know what the wheels are. Anyway, that's how it works. You put that on there. This is an 8mm shaft on this 100 RPM motor. This is, I think, an eBay motor, $32. And so that goes like that. That couples the shaft. There'll be a bearing here, and there'll be a bearing here. All right, so I've been working on the base. I'm using 3/4 inch Baltic birch plywood. I have a 7/8 inch diameter hole I cut with a Forstner bit, and then a clearance hole. And on this side I have just 2 8mm holes for the shaft. Here's the idler assembly. These rotate. The tubing is just used as a spacer, and then I have shaft collars in there holding the wheels from moving in and out. Then this will go where? This goes in here, and the shaft collars, again, keep it from moving back and forth, the shaft from moving back and forth, and that's it. The other one, the drive assembly, what I'm going to do is, this is a bearing that goes into the wheel. So the wheel had this bearing in it. I just popped them out. They're super easy to get out. So I'm going to fill, and I removed one of the dirt covers, the seal rings from there. And I'm going to fill that with a JB Weld, which I like very much for these kind of applications. That will completely freeze the bearing. And then I will pour JB Weld in here. And I'll take a 8mm shaft, and I'll put some scores in it where the wheels are. And those scores will grab the epoxy so that the epoxy can't break free of the shaft. And I mean, there's not much torque needed to turn this, but that should last 2 forevers. Here are the passivated bearings. That's never going to move. There's JB Weld in there. I've got 4 of them. And these go back inside of here, and I'll goop that up with JB Weld after I've passed the shaft through it. And that'll be fine. That's never going to move. So I've got JB Weld mixed up here. The 2 wheels, the bearings that I've passivated or captured with JB Weld epoxy. So the way this is going to work is, well, we'll just do it. I got a bearing on here. It's got the JB Weld also. That's going to go on there. I'm going to goop this up. You notice I've roughed up the shaft on the belt sander, and that locks the epoxy in place really well. Okay, so this is pretty simple, I think. I guess we'll find out. I'll just get a bunch. The whole idea is to get a bunch of epoxy in there. Doesn't matter where it goes because nothing turns relative to the other parts. We just want to lock it all up with epoxy. And that looks like enough to me, so a bearing goes on. The spacer goes on, just a piece of brass tubing. And we'll press that into there. All right. So far, so good. Now, another wheel with a bearing, and load this end up with epoxy. And that will be the whole assembly. I'll put the bearing on it, a shaft collar to hold it all together. Alright, so this hole is filled with epoxy. Just push that in there. Alright, and get a shaft collar on there. Alright, so while the epoxy is curing, on the drive shaft, I really don't care because epoxy isn't going to leak out of anything. So I can finish the assembly of this. So what I'll do is I'll take this off. This is the idler, and it gets a shaft collar. I think that'll do that one. Now this gets, right, this gets a real bearing. This one works. And let me think. No, it gets a shaft collar first, and then a bearing. All right, I just dropped everything on the floor, but we recovered. So I'm trying to put this into here like that. Turn it over and put the screws back in, right? I need a certain amount of length sticking out of here for the coupler, and that's enough. You don't want really any excess. Shaft collar. Should be right there. And that's looking good. So we have a drive shaft. I'll do the same thing over here. I just lock this in place with these shaft collars. That's all together. So these wheels spin on their own bearings. This is all completely captured inside of here by epoxy, so the whole thing turns, and that allows us to drive it with the motor, which I'm going to install next. Okay, here's the motor. Let's see if I got this. Oh, that worked really well. Got the height right, and that should turn. There's the final base and drive. This hasn't cured yet, the epoxy, but that's okay. The motor is on, the coupler, we turn it on, it goes around. Alright, next step, I got a big bag of agates I collected in the desert, and they're very cool when they're, you know, tumbled and polished. They don't look like much now, but they will. So what I do is I want to get rid of this white stuff, or most of it, and I want to shape each rock that I put in there a little bit so that it doesn't take forever to wear off, you know, the sharp points. So I do that with a combination of tools, obviously a hammer, but I also have a little tiny rock saw, and it's a dry saw. I made it using a Makita angle grinder, and this is a diamond, this is a 5-inch diamond blade. And I just made a little stand for the Makita, and the blade goes around. But this thing requires a full set of personal protection. So let me show you what I wear. It's loud, so I wear the ear protection. It's full of silicate dust, so a respirator is mandatory, and then I have a face shield that goes on top of everything. So this is what I look like with everything on. Well, that took about half an hour. I took that bag of rough rocks and turned it into this. You can see I've rounded the edges. That just makes things go a lot faster, and you get a better, in my opinion, you get better rocks, tumbled rocks at the end. So there's a nice assortment of colors in here. Kind of weird stuff. Anyway, we'll see how that goes. I suppose I've got about 12 pounds there, and the capacity of the tumbler should be sufficient to take all of these rocks. And then I throw in a bunch of these because it acts kind of like grit. It helps the process of breaking the rocks down. This stuff will disappear, most of it, during the process. But it's good for the tumbler. So all that stuff just goes in, just like that, and I'll see what I can get into the tumbler. That's at least 12 pounds. Yeah, the grit's in there, the water's in there. I'm ready to seal it up. So I go around and tighten this, circular pattern slowly. Right, here's the big test to see if it'll go around. That's heavy. That is totally full of rocks. All right.